A very good evening, dear students. I hope you all are doing well. And here we are in our next video. Now, this video is gonna be a bit different, yet it is focused on one of the topics that we were going to cover after the study of magnetic field lines and Earth as a magnet. Now, this video will be centered, yes, on the very basic topic of electromagnet and electromagnetism, rather. But yes, uh, this is more of a video to clarify how in physics we are not the inventors of things, rather we discover the things by observing the nature. Okay, so let me put it in this manner, in this way. uh, in physics, the very basic quantity, the very fundamental quantity that we have, there are two. One, mass. Second, the charge. Okay, the very basic of existence of any kind of matter in that form is mass and charge. So if a matter is existing in nature, is existing in space, it will have these two quantities. Now the charge can be of two types, we all know that, positive and negative, and which gives rise to electricity, electric fields and all. Now why I'm saying all this? Okay, let's develop, or let's at least try to develop a very different perspective of looking into things. All right, now imagine two people, two persons. Okay, imagine two persons, one over here, the other over here. Both of them are playing with a ball. Okay, playing with a ball, a simple ball. Now when this person A is throwing the ball to this person B, Newton's third law says that to every action there would be an equal and opposite reaction, right? So that means if this person A, is applying a force in this direction, due to this force, he himself is getting a push in the backward direction, right? That's what Newton's third law says, and that's the very basic fundamental law in nature. All right. Now, from this person's point of view, what is happening? When this person is catching the ball over here, due to this force in this direction, this person is also getting pushed behind. All right. So the ultimate effect, what we can look over here, that is why I said in the beginning that we need to change our perspective a bit. This person on throwing the ball getting a push behind, this person on catching the ball getting a push behind. So if this phenomena continuously goes on and on and on, these two persons are drifted apart, right? These two persons are drifted apart due to these forces. Okay, now if you imagine these two persons as two particles, rather, what is this ball that is being thrown between both of them? This ball is something that is called as a virtual photon. Okay, now I know there are background noises coming. Okay, please be with me. This ball is nothing but is called a virtual photon. Now what is a virtual photon, what is its origin, what is its function, how mathematically we can derive, and why is it important? Let's not dive deeper into it, because the origin of the virtual photon is basically quantum level physics. Okay, now virtual photon is something that gets exchanged between any two particles. Okay, between any two particles, this person A, this particle A, or this person B or particle B, due to which certain phenomena arises. And what are those phenomena that are very important for you to understand? Okay, now try to understand. Let me give you some aspects of this virtual photon. This virtual photon is a mathematical particle that rises from some of the mathematical derivations that we do in quantum level. Okay, in the fabric, if we imagine the space as a fabric, and the more energy this virtual photon has, the lesser is its lifetime. That means if one virtual photon has an energy of 10 units and the second virtual photon has an energy of 100 units, the 100 units virtual photon will have a lesser lifespan than this 10 units virtual photon. Okay, now let's keep those aside. Why we are talking about this? It's a very basic fundamental phenomena to understand. that due to this exchange of photons, now these people, these two persons, or these two particles rather, now that we know these are particles, they are getting drifted apart. Okay, the more closer we bring them, the more rigorous transfer of photons happens. Try to understand, when the distance between these two particles are much apart, okay, they're further away, the the virtual photon have much time to travel. The more closer we bring these two particles, the faster it travels, right? The more energy it has. Okay, now this the push that they are experiencing, this is what we call in our general language as repulsion. Any kind of repulsion happening, now don't connect this repulsion to anything else, okay, just repulsion. Any kind of repulsion that is happening, that is due to this exchange of virtual photons between particles. Now this is one form of particle that we have seen. Now comes another form of particle. Okay, now come another form of particles. Now this particle behaves in the similar way, exactly same way. It exchanges virtual photons and it repels similar form of particles, so there is a repulsion acting. But when we examined, when we performed those experiments in between these two particles, somehow what we have observed, again, somehow what we have observed is that the exchange of virtual photons between these two kind of particles is somewhat different. How it is different? Now purposely I have chosen one smaller ball and one a bit bigger ball, the another one. There's a reason. Okay, now when we see the behavior of the exchange of virtual photons between these two particles, we see that somehow the exchange of particles from this and the exchange of particles from this white ball is in a way that they are not getting repelled from each other, rather they are getting attracted to each other. Okay, that means these are two different kinds of particles. Okay, later on we have named one as electron, we have named the other one as proton, or rather more fundamental way, we have named one type of charge as negative and the other type of charge as positive. Okay, so these two charges, that's how we know that these two charges, that is opposite charges, they attract each other. But if this have a similar one over here, they will repel each other. Okay, and same goes with this electron, they will repel each other. And from there, dear students, arise the phenomena of electrical field. Okay, what do we mean by an electrical field? If you see somewhere there is a surface written, or somewhere there is an area, that's a wrong definition of field. Okay, just because it's a field, it doesn't need to have a 2D surface. Okay, we'll talk about surfaces and planes and dimensions in another video. This is what gives rise to electrical field, and from where the later concept of electricity and everything rises. All right, now we have, what do we have? What is the conclusion by now? One particle positively charged, one particle negatively charged, and we have seen by the properties that the exchange of the virtual photons or the energy particle is somewhat that this one accepts it and this one emits it. Okay, so that is why, while studying static electricity or while studying current electricity in higher grades, when we draw the electrical field or the nature of the electrical field in our notebooks, we denote the electrical fields going out from a proton or positive charge. Rather we do draw it in an opposite manner, that is coming inwards or coming inside, accepting, okay, from an electron. So this goes the phenomena of electrical charges and electrical fields. Okay, now we dive a bit deeper into some of the concepts. Okay, what is the concept? It's a very infamous one, that is called relativity. Okay, or special relativity by Albert Einstein, of course. So relativity says the faster an object travels, the length of that object gets shorter and shorter towards the direction of travel. That is one statement given by Albert Einstein. What does that mean? For example, I would like to give an example using the marker over here. So if you see this to be imagine a space explorer or a spaceship of this length. Okay, now imagine this is the head side and this is the foot side or the propulsion side. Now this is the head side. Now this spaceship is traveling in this direction like this. Okay, it is traveling like this. If it travels somewhat closer to the velocity of light, okay, this is an whole equation that we are not going into. what happens in theory of relativity, according to theory of relativity, is that the length of this marker would get shorter and shorter and shorter. In which side? In this side. Since it is traveling in this side, so it will be shorter and shorter and shorter over here. If it would have traveled in this way, it would be shorter and shorter and shorter in this way. Okay, that's what relativity says. Now let us take an example of a conductor. What do you mean by a conductor? A simple wire, copper wire or iron wire, which allows the electron to flow. Okay, now you might be wondering why I'm walking around, because the electrons are also moving. Why not me? So let us try to understand electricity and relate it to magnetism from a different perspective or from a different point of view. So what is happening? We have these particles lined up. Those are the positive particles. Let's not name it right now. And we have the other set of particles, the negative particles, lined up over this side. Okay, the left side and the right side of the video. Okay, you imagine by yourself. So the positive particle, as we see, have a tendency to push the virtual photon away from it. Okay, and the negative particle, that is the electron, we see that it is in it have an accepting nature. All right, so this whole thing creates a kind of force or a kind of potential or a kind of field in the whole of the conductor. Okay, now when this happens with billions and trillions and quintillions of particles, there's where it gives rise to something called electricity. Okay, or the flow of charges. In your childhood, you must have defined, I guess, electric field or electricity, or current electricity rather, as the flow of charges, right? Okay, so this is how it flows. Okay, this is what is basically happening. Like, if this is the positive charge, if this is the negative charge, okay, this negative charge, due to its free nature, okay, you know, the atomic structure and the electrons orbiting around the orbit. So some of the electrons, they are free electrons. Okay, they are free electrons in the conductor, the nature of the material, if it is conducting. So it gets a pull, it flows in a certain direction. That field that we have discussed till now is what makes them flow in a certain direction. All right. Okay, now comes the main concept. Why I talked about relativity over here? You see, relativity says that when there is a motion, okay, and when the particle or when the length is moving, it gets shorter and shorter towards the direction of motion. Okay, now imagine, okay, totally based on your imagination, imagine a conducting wire over here. Okay, imagine a conducting wire. Here there are equal number of electrons, here there are equal number of protons. All right, now if I bring a positively charged something, a ball, a guava, an apple, okay, whatever you like, closer to the wire, what is happening from this ball's point of view or this apple's point of view, and what is happening from the charge's point of view? There's this term called frame of reference in physics. Frame of reference is just your POV, okay, just your point of view from where you are observing the thing. A very simple example of frame of reference is if I'm traveling somewhere, and my maybe when I traveled here, okay, so I was sitting in a train and my parents were standing on the platform on the station. Okay, so from their point of view, the train along with me was moving forward. From my point of view, they were moving backward. That is what POV means. That is what the frame of reference means. Okay, now if the electrons are flowing this way, okay, in the conductor, as electricity is flowing from this ball's point of view, so, or from this apple's point of view, if we see what is happening in the conductor, we would see that the positive charge, in case they are moving backwards, right, from his point of view, okay, we would see that the positive charges are moving backward, as we see from inside the train, that a platform along with the buildings and trees, they are moving backwards from my point of view. So from his point of view, those charges are moving this way. Now if those charges move this way, according to theory of relativity, the length gets shorter. What length gets shorter? The space between two charges, they get shorter. That means if the length between these two charges gets shorter, they get accumulated over this length. They are getting accumulated. and the opposite or the vice versa is happening with the negative charges. Since they are moving in the backward direction, the length between them increases. Again, relativity. Now try to understand something phenomenal happening over here. Okay, if the charges, rather the positive charges, get accumulated over here, the amount that was getting cancelled, that means the if there were 10 electrons, 10 protons, the charges attraction and repulsion get cancelled. This doesn't have any effect, it stays where it is. But according to relativity, what it says, that the positive charges are accumulated over here, so there is a more number of positive charge in this span of length of the conductor than the negative charge over there. That means due to this accumulation of positive charge, it will repel, it will start repelling this positive apple or the positive ball. Now if I give this ball also a push in the forward direction, so from this ball's point of view, or from this apple's point of view, it is getting a push from the wire unknowingly for whatever reason in this direction. But from my point of view, from a third person's point of view, who is observing the conductor as well as this ball or this apple, it is only moving in this direction. But due to this relativistic phenomena, it is moving here and also getting a push there, so the relative motion is like this. Are you getting my point? One motion in this side, one motion in this side, so the vector addition, the direction becomes like this, curved path of motion, like this it is moving. Okay, this unknowing force is basically what we refer to as magnetism or magnetic force. Confusing a bit might be. What I'm trying to say is, you see, this is how the nature of magnetism is. Okay, it arises from something very basic as a charged particle, or that we commonly known as electron. Okay, so nothing is not related to each other. The whole universe is related to each and every atom. We'll talk on that in our further videos. Okay, so till now what we have understood, let us summarize a bit and let us discuss the next part of it in the next videos. Particles exchanging something, you don't need to remember. Okay, that is why the repulsion takes place. The movement of that, including the special theory of relativity, gives rise to a weird effect. Okay, something very fantastic, or rather something very confusing might be. Okay, if we start thinking from the particle nature or the quantum level, that force that is getting generated over here due to this relativity phenomena and the movement of this particles is what magnetism actually is. So this is the basic and core reason how the force of magnetism is originated in the first place. Okay, so it is nothing but the movement of the charged particles. Again, if the particles are not moving, there is no accumulation of those particles, no relativity theory of relativity taking place, and no pushing further of this particle is taking place. I hope you have understood the origin of magnetic forces. It's not a weird force that why suddenly this particle will push this away and this particle will push the opposite poles and all, and attract the opposite poles and all. Okay, everything has a reason behind it. So that was the basic reason behind me making this video, to make you understand the connectivity or the connection between the topics that we study. And this is not the end. We'll continue this video by explaining the concept of permanent and electromagnet further in our next videos. So again, let me start moving because the electrons are also moving. Okay, bye bye, have a nice day.